In this video, I talk about generators in Python and when to use it. Let's get to it. Hi guys, Arun here from Nifty Tutes to guide you with your educational probes. To understand generators, you should first learn about iterators in Python. Please find the link in the description for the video that I've made about iterators. I would recommend you guys to watch it before going through this video. Alright, now let's talk about generators. The generator can make normal Python function to behave like an iterator using the keyword called yield. Let us take the same example square class that we used in the iterators video. The constructor of the square class takes limit as the input with self and assign it to an instance variable called end value. It also has an instance variable called start value which is equal to 1. It has iter method that returns self and the next method that returns square of the start value and increments the start value by 1 if start value is less than end value, else it raises stop iteration exception. Here, to create an iterator, we had to implement both iter and next methods. That's a lot of code. We can implement the same thing with less lines of code using generators. Let's try to implement the same functionality using generators. Here we have a function named square that takes an input called limit. It has a local variable called start value that is equal to 1. The while loop here checks if start value is less than limit. If that's true, it yields the square of start value and finally increments the start value by 1. This yield keyword right here returns a generator object. Let's assign this function square with value 3 as input to a variable s. If you check its type, you can see that it belongs to the class generator. Actually, generator is an iterator. The generator is a subclass of the iterator class. As I mentioned in the iterators video, if a class has both iter and next method in it, then it's an iterator. Let's check the methods of this S object. You can see that it contains both iter and next method by default. This yield keyword creates both iter and next methods automatically. Now, if you call this function, you won't get anything. You must use next method to access its values. For example, let me call the next method by passing this S object as input. You can see it had returned 1, which is the next value in the sequence. If I call this one more time, you can see now that it had returned the next value in the sequence, that is 4. What if I call this method one more time? Notice that it had thrown stop iteration exception just like iterators. Let me comment all this. One more important thing is we can use the generator object directly in the for loop just like iterators. You can see that it just works fine.
Awesome. Earlier, I mentioned that every generator is an iterator, but keep in mind that every iterator is not a generator. In that case, what's the difference between iterators and generators? The main difference is an iterator object can be used multiple times, but the generator object can be used only once. You cannot use it again if it had iterated to the last value of the sequence or it had thrown the stop iteration exception.
For instance, let's take this square iterator class. In else block, if I add start value equal to 1, you can use this iterator object multiple times. Every time the start value gets assigned back to 1 before raising stop iteration exception. Let me use the same object again in one more for loop. You can see that it had generated the square values twice. The second for loop has generated the square values from the first element again, but that's not the case with the generators. If I use the same generator object with one more for loop, you can see that it had generated the square values only once. To use this generator function again, we must create a new object. Alright, You can also create generators with even less lines of code. Generator expressions that is very similar to list comprehensions can also be used to create generators. For example, let's say we have this expression here allow us to create generators. If you check the type of object yes, you can see that it belongs to class generator and it has also generated the square values as expected. We have successfully implemented the square iterator class with just one line of code. That's awesome, isn't it? All right, now let's get to the actual question, when to use generators. To explain that, here I have written two functions. One is normal function and another one is generator function. Both do the same thing. In normal function, it's not possible to compute a square value and return one by one. We have to compute square values of all the elements at once, store it somewhere, and return the object that stores all the square values. In our example, we compute square values for million elements and store it in a list. Now, the size of the list is going to be huge. It would consume more memory. If I run the same function for 10 million elements, you can see that size of the function object has been increased even more. But that's not the case with the generators. You can see that the generator function object size is same for both 1 million and 10 million elements. That's because generator doesn't store anything. It only stores state of the object. You can see I didn't use any list to store square values that is calculated by this generator function. That's because it haven't calculated yet. The next value of the sequence will get calculated and returned only if I call the next method of this generator object. So the key benefits of using generators are it would take less lines of code to implement and it would consume less memory to execute. Thanks for watching. If you like this video, please give a thumbs up and subscribe to this channel for more. Hit the bell icon to get instant notifications. If you have any queries or feedback, feel free to leave it in the comment section. Thank you guys once again, and I'll see you in the next tute.